So as I've been kindly introduced, I won't go into an intro about me. Although humbly, I'm not a data scientist. Although I'm fascinated with this area, we have brilliant technical people within Intro who are responsible for delivering value to our customers using these technologies. So as you're aware, we use data science to help our customers hire people from within the networks of the collective organization. And the organizations that we're working with are fast-growing technology companies. And I won't go into the reasons why we're targeting only this segment, but what's important to note is that I'll be running through the product and highlighting key areas within the application where data science is used. And as you will see, it's a fundamental aspect of our application. So the first area which I'm going to be taking you through is to the team section. And this is where the recruiter, who is our primary user, will be inviting their employees to participate in the referral program. So Intro is coming in and revamping employee referrals within the company, and they can invite their users directly in Slack. And once they have done so, the employees will receive an invitation and be invited to connect their network. How they connect their networks is the important area which I'd like to discuss with you. And they do this via installing a Chrome extension. And this is how we parse their LinkedIn contact book. And we use active or real-time data processing techniques for this. And this stands between the application and web services layer and the database layer. And the main functionality here is for real-time data processing. And I'll be explaining in practice what that means shortly. The second area is the job section. And what this area is the basis of our matching algorithms and a fundamental area of where we parse referred candidates back into the applicant tracking system of our customer. The applicant tracking system is the central nervous system within the HR departments of our customer. So we are providing referred candidates for them to continue with their interview process. And some of the techniques that we use once we've synced using an API, and it's a Harvest API, it's a two-way sync, meaning we pull in the jobs and then we use an NLP module, and then this is the first part of our NLP pipeline to convert this into structured data. Some of the things that we extract in terms of the outputs afterwards, after we've extracted it, is job title, skills, experience, where possible. And then we use semantic algorithms and word synonyms to build word trees which can expand or contract. So for instance, JavaScript, React, and front end are all quite similar. We then go online and we crawl publicly available sources for our customers to understand who in their employee networks are suitable for job positions. And the sources are visible here. They include GitHub, LinkedIn, Stack Overflow, Crunchbase, and several others. And some of the techniques that we use here is to surface promising candidates and give our customer and the primary user, the recruiter, an understanding on the relationship between the candidate, where their name, location, their job title, and the company that they're working for, and their employees. And we do this by cross-referencing education and work history to see if they've worked in the same location at the same time during the same years. And the business purpose here is that the employees here are likely to provide a strong referral for Cyril. It means that there is a high likelihood of, first of all, a response, which is a very difficult thing when recruiters are going out and reaching candidates cold, but also obtaining valuable reputational data. What happens thereafter is that the employee will receive a Slack notification. So after the sourcing is being done and you can request your intros, the employee will receive a Slack notification where they'll be able to provide feedback as to what this person is suitable for, if indeed anything, or they can decline, and they can make a referral. Some of the techniques that we plan to be using, although not using now, can be active learning. So we are correcting here if this person is coming up as a colleague, but the employee marks as a friend, and things like that. And then they'll be able to make the referral, and then at the end, the customer is able to receive valuable reputational data, which they'll be able to push into their ATS and continue with the work of hiring that person. Some of the lessons learned has primarily been orientated towards simplicity and convenience. And what I mean by that is some of our customers are very well-established companies that have raised hundreds of millions of dollars. And we initially assumed that they would want some of the deepest techniques to enable more hires, when frankly, that just isn't the case. The simplest solution and tackling it and then building from then has ensured that we've saved a lot more time in the long run. And that goes, for instance, with regards to connecting your networks. Previously, it was conducted via downloading files. Now it's automated with a Chrome extension. And this also is informed by our matching algorithms. We were attempting previously to use Siamese neural networks to try and identify matches, when in fact, firstly, going with job titles and then skills and then experiences has led us to be the most appropriate way. And furthermore, trying to understand what the value, what the customer wants is really the golden rule here. A lot of information that can be found online, particularly about work history, is often been created by the candidates and may not necessarily be accurate. Or indeed, the best candidates may not have the most information. So just relying on specific areas and techniques to try to match algorithms with data found online isn't always the best case. And using your employees to provide that data creates your own proprietary data sets, which can then be much more effective in the long run. Where we're going is incredibly interesting for us, because we intend to implement a graph database, and particularly that's going to be Neo4j. And the database is effective for a variety of different reasons. The first reason is that, unlike relational databases, relationships within Neo4j are first-class entities, and each relationship has a type, a direction, an unlimited number of properties, where we're able to capture the duration, quality, and the degree of influence of data. So the second part is also that we are working within social networks, and social media networks are already graphs. So there's no point of converting the graph into tables and then back again. So this interconnected social data is neither linear or purely hierarchical. So that architecture will make our application extremely fast, and not force immediate indexing at every turn. And the ultimate objective, thirdly, is that we can build our own QR AI model, which learns the kinds of applicant skills and experience that our customer wants, based on the hirer's engagement with past candidates and job descriptions and profile of customer themselves. And then we'll use this model to help our customers find the best people within their employees' networks, and prevent potentially great candidates from leaving. That is, in short, a brief intro into Intro.